just a recap of what I did last class. Well, the last thing that we did. Factorizing polynomials, we said. Quadratics. We know how to factorize quadratics, right? Quadratics are also considered polynomials in the second degree. But the problem is, how do you factorize a polynomial that's to the third degree and higher? Well, we said to do that, if we're given one factor of the polynomial, then we can use long division to find the other factors of the polynomial. And that's how you factor a polynomial of the third degree and higher. And then we went through the steps on how to do it. Sometimes you're given the factor. You see that in the past papers when we start the past paper. Sometimes you're given the factor already, and all you have to do is the long division. But other times, they expect you to find the factor first, and then you long divide. So how exactly do you find a factor of the polynomial without long division? Well, we said that you would use the factors of the constant term. So in this case, the constant term is -3. And using those factors of the constant term, -3, you could find out what is a factor of the polynomial. So that's what we did last class, right? All this, we found out that one of the factors was x plus 1, and then using x plus 1, we did long division to find the other factors. So we said that this, which is called the divisor, and this, which is called the quotient, they are both factors. So that's why I have here the factors are x plus 1 and 4x squared plus 4x minus 3. However, we said we wouldn't leave it like this. Why? Because this quadratic right here, it could factorize. So not all the time it would be able to factorize, but this specific quadratic, you could factorize it. And that's why I have the factors are x plus 1, 2x plus 3, and 2x minus 1. That's if they ask you to find all the linear factors of a given polynomial. This would be my answer. If they ask you to solve, all you have to do, just like when you was solving by factorization, when you're doing quadratics, you put each factor equal to 0 and you solve for x, same thing. So I have 1, 2, 3 factors, I put each one of them equal to 0, and I solve for the values of x. For this question, my answers were x is equal to 1, x is equal to -3 and 2, and x is equal to a half. So that's what we did last class. And now I just want to do the past papers. If you have any questions, let me know. Number 1, C. Did I do this? No, we didn't do this one. Okay, so we'll do this one. Okay, so this is the question that we're doing. 2015, number 1, part C. You could just write down the question and then I will do it with you. So the first thing you want to do for any question, any worded question, worded problem, you write down all the information that they give, right? So what information did they give me for this particular question? Well, they told me that the polynomial in this case is 2x cubed minus 5x squared plus x plus 2. And then they told me that a factor of this polynomial here is x minus 2. So let me just put that in blue. Factor. Oh my god. They told me that the factor is x minus 2. What they asked me to do? Well, they asked me to completely factorize this polynomial. We said in order to factorize a polynomial, we need one factor. So this is my factor here. If I'm given one factor, then I can use long division to find the other factors. And that's exactly what we're going to do. Remember on the PowerPoint, I said the first step was to use factors of the constant term to find a factor of the polynomial. But then I had in brackets in green that you don't always have to do that step. Why? Because here you're already given a factor, so there's no need for you to go and find one. All you have to do is the long division to find the other factors. Okay, so let's do that. Long division, right? We said that's what we do. So let me just clear. We went here to do long division last class. 2x cubed minus 5x squared plus x plus 2. And we are dividing this by x minus 2. Because this is a factor, they told me that this is a factor of this polynomial. When I do all this long division, my remainder is supposed to be 0. So what does that mean? If you get a remainder that is not 0, then something is wrong, right? You did something wrong and you need to go check it over. So that's just a little tip. Because they told me it's a factor, my remainder must be 0. If your remainder is not 0, you did something wrong. Check over. Okay, so let's long divide. X into 2x cubed, that's 2x squared. 2. Bro, what's my? Oh, that's a 2. Multiplied by, so 2x squared multiplied by x, that's 2x cubed. But of course, you can't just neglect this minus 2, right? You also have to say 2x squared multiplied by minus 2, which gives me minus 4x squared. And then remember, when we do a long division, we always subtract them. We always subtract the terms. So 2x cubed minus 2x cubed, that's 0. You don't have to put the 0 if you want to, you could, right? But it's understood. Next term, minus 5x squared minus 4x squared. So let me just circle that. Minus, a minus and a minus is a plus, right? So that becomes minus 5x squared plus 4x squared, which is minus x squared. Then you bring down the other term. My other term is x, so that's plus x. Then we repeat the process. X into minus x squared, that's minus x. Then minus x multiplied by x, that's minus x squared. Minus x squared. Can't forget the minus 2. So minus x multiplied by minus 2, that's plus 2x. So the minus and a minus gives me a plus. Remember, we are always subtracting the terms. So minus x squared minus x squared. We know when we see two minus signs, that becomes a plus. So what does that mean? That means minus x squared plus x squared, which is 0. You don't have to write a 0. Then x minus 2x, that's minus x. Bring down the next term. The next term is plus 2. Repeat the process again. X into minus x, that's minus 1. Minus 1 multiplied by x, that's minus x. Minus 1 multiplied by minus 2, that's plus 2. Why? A minus and a minus gives me a plus. Remember, we subtract in the terms. We always subtract in the terms. Minus x minus x gives me 0. Why? Because a minus and a minus is a plus. And then I have plus 2 minus 2, which is 0. And because my remainder ended up to be 0, I know that I did this correctly. And I don't need to check it over. I did it right. Yeah? But if your remainder was not 0, like if you got another remainder, then you know something is wrong and check it over. So back to the question, what did they ask me? They asked me to completely factorize this polynomial. This is a factor. This is a factor. Last class, I showed them an example. 228 divided by 2. That's going to give me 64, right? We know that 2 is a factor of 128. How come? Because 2 divides 128 without leaving a remainder. 2 into 128 is 64. Similarly, 64 is a factor of 128. Why? Because it divides 128 without leaving a remainder. 128 divided by 64 is 2. Therefore, we can say that both the divisor and the quotient are factors of 128. Same concept we're using here, right? Both the divisor and the quotient are factors of this polynomial. So they asked me to completely factorize this. Well, now that I did my long division, I know that this right here is a factor, so x minus 2 is a factor, and also this quadratic up here is also a factor, 2x squared minus x minus 1. But I told you sometimes these quadratics, sometimes they're not able to factorize them, right? So that's why you have to check. You have to check to see if it would factorize. So would 2x squared minus x minus 1 factorize? Yes, it would. So what do we get here? Let me erase this so I could clear this, right? Yes, no? Can I clear this? I'll clear it. Just found out these two are my factors. And we're looking to see if this quadratic here could factorize. Because if it could factorize, you have to factorize it. That's why in the past paper, I think they put it in italics, completely factorized, right? That's what they mean by completely factorizing. If this could factorize, you must factorize it. So let's see, could it factorize? So what two numbers when added will give me -1, but when multiplied will give me -2? That would be plus 2x. No, not plus 2x. Minus 2x plus 1. Well, plus x. Minus 2x plus x. And then we leave the -1. If I factorize these by grouping, I see both of them have 2x in common, so it's equal to 2x. What I remain with is x squared. I mean x minus 1, my bad. X minus 1. This one, this is x minus 1. Therefore, what are my factors? It's understood that 1 is in front here, right? So what are my factors? My factors are x minus 1 and 2x plus 1. Therefore, what is my final answer? Well, my final answer would now be, instead of putting this, what I would now put is x minus 2, x minus 1, and 2x plus 1. This is my final answer. This is what they want. Okay? So I'm going to erase now. If you need me to stop, just let me know, right? Okay. This is the second paper we're going to do. 2013, number 1, part 2. Number 1, part 2. Oh wait, let me just show you. See, completely factorize. Well, factorize completely. It was 2 months. I mean 3 months. What am I saying? 2030 number 1 part 2. We did this first part in class, in the last class. This is what we're doing now. They want me to find the linear factors. What does that mean? That means they want me to factorize. How do I factorize? I take one factor of the polynomial and I use that to do long division so I can find the other factors. So just write down this question for me and I will go through it. This is the factor up here, right? So this is the factor given and then this is my polynomial. Okay, first thing we're doing, we're writing down all the information that they gave. What information did they give me? Well, they told me that a polynomial, this function f of x, is given as x cubed minus x squared minus 14x plus 24. What else did they tell me? Well, they told me that a factor of this polynomial is x plus 4. They told me that, right? The factor x plus 4. But what did they ask me to do? Well, they want me to find the other linear factors. What does that mean? They want me to factorize the polynomial. How do we factorize polynomials? Well, using the factor that we have, if we're given a factor of the polynomial, all we have to do is do long division so that we could find the other factors, right? That's how we factorize polynomials. So that's what we're going to do now. I need all the space. So let me just clear this over. That's the information that they gave us, and now this is the long division. Polynomial is x cubed minus x squared minus 14x plus 24. We're given a factor, which is x plus 4. Remember, if it's a factor, the remainder would always be 0. So your remainder, after you do this whole long division, is supposed to give you 0, right? So let's start. X into x cubed, that's going to give me x squared, and then x squared, x squared, multiply by x, that's going to give me x cubed. But you can't neglect this plus 4, right? So now you have to say x squared multiplied by 4, that's going to give me plus 4x squared. Remember, we always subtract the terms. So x cubed minus x cubed, that's going to give me 0. You don't have to put the 0. If you want to, you could write it, right? And then minus x squared minus 4x squared, that's going to give me minus 5x squared. You bring down the next term. The next term is minus 14x. All you do now, repeat the process. X into minus 5x squared, that's going to give me minus 5x. Minus 5x multiplied by x, that's minus 5x squared. Minus 5x multiplied by 4. Remember, you can't neglect the 4. You have to multiply by 4 as well. That's going to give me minus 20x. We always subtract the terms. Minus 5x squared minus minus 5x squared, So very important, right? Minus under minus gives me a plus. So this is the same as saying minus 5x squared plus 5x squared, which is 0, right? Next terms, minus 14x minus minus 20x. Minus and a minus gives me a plus. So this is the same as saying minus 14x plus 20, which is 6x. Bring down the next term. The next term is plus 24. Repeat the process. X into 6x, that's plus 6. 6 multiplied by x, that's going to give me 6x. 6 multiplied by plus 4, plus 24. We always subtract the terms. 6x minus 6x is 0. 24 minus 24 is 0. Remember, because this is a factor, my remainder must be 0. If you got a remainder that is not 0, you did something wrong, check it over. Because I got 0, I know, okay, this is most likely correct, right? So back to the question, what did they ask me to do? They wanted me to find all the linear factors of this polynomial expression here. He said the divisor, both the divisor and the quotient are factors, right? So that means this is a factor and this is a factor. They asked me for all the linear factors, therefore the factors of this polynomial are x plus 4 and x squared minus 5x plus 6. However, this is a quadratic. If your quadratic can be factorized, you must factorize it, right? If you don't, you will lose marks. So we know that not all quadratics can be factorized. So you need to check to see if this can be factorized, right? If this can't be factorized, well, this would be my answer. But this could be factorized. So let's do that now, right? Can I clear this? Yes, no? Okay, well, I am clearing this. So this is my quadratic here. I need to check to see if it can be factorized. Because if it can be factorized, I must factorize it, else I would lose marks. Okay, so what two numbers when added would give me minus 5, but when multiplied would give me 6? Those two numbers would be, right, minus 3x minus 2x plus 6. Factorized by grouping, that's x minus 3 minus 2, x minus 3. What does that mean? My factors are x minus 3 and x minus 2. So what would I write for my answer here? Because they asked for all the linear factors. Well, the linear factors of the given polynomial expression would be x plus 4. But instead of writing back this quadratic, I know that I can write x minus 3 and x minus 2. So this right here, this is my answer. The factors of the polynomial x cubed minus x squared minus 14x plus 24, the linear factors are x plus 4, x minus 3, and x minus. Good afternoon. Can I clear this now?
Wait a minute. Let me take a picture.
Okay.
Yeah, you can clear it now.
Okay, this is 2013, number 1, A part 2. All right. So what we doing now? This is what we did. I don't even remember if we finished it.
Okay. Oh, I learned that yesterday. No, I relearned that yesterday at school.
Okay, cool. This is the last past paper question we have to do. That's it for past paper question. That's it for polynomials. Ask me any questions after. So this is what we're doing now. Paper 2, 2019, number 1, 8. 2019. Scroll down, scroll down, scroll down. This is what we're doing. Wait, I think we did this one already, but we'll do this again. And then we also doing this. Okay. We're doing part 1 and part 2. So just let me know when you write this question down, and then I will do it. You finish writing this down?
Yes, Reese.
Okay. Okay, well, let's start. So let me just show you one thing before we start that. Remember when I was telling you when factorizing polynomials, sometimes they're given the factor, so all you have to do is the long division, but other times they don't give you the factor. They expect you to find one of the factors and then you could do the long division, right? That's when this step comes in. You need to use the factors of the constant term. Using that, you need to find one factor of the polynomial. Only then can you do long division, right? This question is what I was talking about. It's an example of that. What am I doing? So what did they tell us? All they did was that they gave us a polynomial expression and said to find the linear factors. Oh my. The polynomial expression, which is to the third degree, is 2x cubed plus 7x squared plus 3x. Oh, hold on. Oh, wow, interesting. Anyways. Two, three, four, five, squared. Okay, so this is what they gave us. I don't know what they called it. Let me just leave it as x, right? This is the polynomial expression that they gave us. They told us to find all the linear factors. But if you look at this, right, this is different to the polynomials that we were doing. Because the other polynomials, they actually gave you a constant term. So on the PowerPoint, the constant term was -3. In this case, you don't see a constant term, but don't get worried. It's the same thing you're doing. That just means that the constant term is 0, right? Same thing you're doing. Factors of 0. So literally anything could be a factor of 0, right? Anything into 0 is going to give me back 0. Okay. So what am I doing here? Factors of 0. Factors of 0 would be an infinite set, right? But remember, this is always trial and error. So you need to go through each factor of 0 and you need to see which one. When I substitute that value, if I would get my answer to be 0, right? So what are we doing? If I said, okay, 0 is not a factor of 0, right? Because you can't divide anything by 0. You will get an invalid answer at this level, right? So what I would say, 1 is a factor of 0. If I'm finding f of 1, that means wherever I see x in this polynomial expression, I'm going to substitute it with 1. So that's 2 to the 1 cubed plus 7, 1, not minus 1, 1 squared plus 3 times 1. What am I going to get? Well, 1 cubed is 1, so 1 times 2 is 2. This is plus 7 plus 3, which is going to give me 12. 12 is obviously not 0. Because my remainder is not 0, what does that mean? This is not a factor. So then you try x, then you try minus 1. Okay, so this is 1, then you try minus 1. So this is always a trial and error thing, right? You have to, I know it's long, tedious, but you have to do it. That's the only way you could find the factor. So x, when x is 1, that didn't work. So what I move on to is minus 1. If x is minus 1, would my remainder be 0? Well, let's see. 2, I'll replace this with minus 1 cubed plus 7 minus 1 squared plus 3 minus 1. Or I just saw the message about the PowerPoints. I already posted all of these. No, I didn't post this. I have to post this after class because that's when we finish the topic. I like to post it after. Okay. Yeah, back to that. I'll post it tonight. Okay. So minus 1 cubed, that's minus 1. Minus 1 times 2, that's minus 2. Minus 1 squared is 1. 1 times 7. Why do I have a minus 1? 1 times 7 is 7. 3 times minus 1, that's minus 3. So this is 2. 2 is obviously not 0. What does that mean? This is not a factor. If this is not a factor, well, I move on to the next number. What's another factor of 0? Well, I can try plus 2. Let's see if plus 2 would work. So I know this is long, but this is what you have to do. You have to go through all the factors to see which one works. Well, I obviously know that 2 would not work, right? If you just look at this, you would tell that 2, 7, and 2 would not give me 0, right? But let me still do it. 2 cubed plus 7, 2 squared plus 3 by 2. This obviously will not give me 0.